Hey everybody, Mr. Tima here, coming to you for part 4 of your astronomy notes. Okay, and part 4 is about the layers of the sun. And again, it's one of these things that you're going to need to know these 8 layers of the sun or 8 parts of the sun. And I know there's one part that I have blanked out here because we don't need to know about it, and it's these right up here. But don't worry about it. I know it says 1, 2, 3, 4, 5, 6, 7 to 9. Just pretend 8 is 9 or whatever. But we're talking about this part right here. So here we go. Layers of the sun. Okay. So the sun has an interior layer. It's composed of the core, the radiative zone, and the convection zone. What's nice is if you can think about the Earth, you kind of know these. There's the core of the Earth. Well, that's the center of the sun as well. It's also the core. That's where fusion takes place. The radiative zone would be like the inner mantle of the Earth. But the radiative zone is literally where the energy, the fusion energy from the middle of the sun radiates through to what's called the convection zone. The convection zone would be like the outer mantle of the Earth. Okay. This would be like where the lava and all that kind of stuff is on Earth. And really, the sun's rate or convection zone is kind of the same. It's governed by convection currents, okay, which means that the hot rises and the cold falls. But instead of it just being like hot air and cold air rising and falling, this is like the liquid of the sun. Okay, so core, radiative zone, and then the convection zone where there's a constant state of fluctuation going on, where all the hot stuff from the fusion layer comes up and the cool kind of sinks back down in there. And that's the convection zone. The sun's exterior is made up of 3 parts. It's known as the photosphere, the chromosphere, and the corona. Okay? The photosphere is the surface of the sun. It's where light is given off. How do I remember that? Well, it's real simple. If I was to take a photo of the sun, I would see the surface of the sun. So photosphere is the surface of the sun. I also think when you take a photo, a lot of times a flash goes off. So photosphere, surface of sun, and also where light is given off, because that's the flash. The chromosphere is like the atmosphere. Okay, the chromosphere is the atmosphere of the sun. That's like where if you think of the floor underneath your feet as the photosphere, we could think of the chromosphere as the atmosphere that if you were to live on the sun, that's where you would live. And then the corona, which is actually Spanish for crown, okay, is the hazy outermost layer. And that's like when you look at the sun and you see that like kind of ring around the sun or that fuzz. That's why when you look at the sun, you don't really see just a ball up there. You see this like fuzzy thing. Well, that fuzzy thing is the corona. It's the crown on the outside. When you were a kid, you drew little squiggly. You used to draw a circle, and the little squiggly lines would be the crown or the corona. Some other terms we need to know are things like sunspots. Sunspots are dark areas on the surface that are cooler than the surrounding areas. So, unlike Jupiter, Jupiter has a giant dot, okay? And that dot's there. It's a giant hurricane, and it kind of moves, but it's always there. When you look at the moon, there's craters, and those craters always stay there. Sunspots are like freckles on the sun. They're cool regions, and as they get really cool, they sink down, and then hot regions come up. So this is an infrared image of the sun, and this is like a really hot spot. So a sunspot may be occurring over here where it's darker. Okay, but eventually what's going to happen with all that convection going on, we're going to have these darker areas are going to become really hot, and these hot areas are going to become cool. So the sun is in a constant motion of sunspots, freckles, kind of shimmering. That's why when you see surface of the sun, they kind of shimmer, if you will. This right here is called a a prominence. I almost said Prometheus, different. Prominences. Prominences are arching columns of gas on the sun. If you ever played Star Fox or any of those, there's a lava planet where you fly through them and stuff. You can think of these as giant archways, like eruptions of plasma from the sun, but they're connected to the sun still. Okay, so it's like they're still on the sun. There are eruptions. They're there. They're arching columns of gas that have erupted from the surface. That's a prominences. Okay, if you're a prominent student, you're someone that stands out. Well, these are things that are standing out from the sun. Sometimes the magnetic field strength is great enough that they will burst off of the sun. And once they burst off of the sun, once they leave, so there's like a prominence right here, you can see it. But once that plasma leaves the surface of the sun and sprays out into our solar system or out into the universe, and you can kind of see some of the sunspots here, all these little dark regions and they have bright regions. Okay, those are called solar flares. And you can actually, this is a time lapse photo here, and you can kind of see down here there's a prominence, and then you can see it kind of moving out here and ejecting. That is called a solar flare. That's when the gas actually leaves the surface of the sun. And you may have heard of solar flares. When we get a high, this is happening all the time, and solar flares are erupting out of the sun all the time. When we get a high concentration and the Earth's very close to the sun, well, it starts interfering with our cell phone signals, satellite television. You may have heard of this before. All right. Let's take a second. I want you to pause for a second, and I want to see if you can fill in the parts of the sun. So go ahead and pause the video and come back, and let's check your answers. All right, welcome back. Hopefully you paused that. Hopefully you're at least trying to do that. Hopefully you at least got some of these. So number one, the most inner part of the sun where fusion takes place. Number one is the core. Number two, just outside the core would be the inner mantle of the Earth, but here is where the fusion moves through. It kind of squiggles through, so that's the radiative zone. Okay, number three would be the outer mantle on the Earth, but this is the part that's constantly moving up and down, hot and cold, hot and cold. That's the convection zone. All right, number four. Number four is the surface of the sun. This is the surface of the sun, okay? This is the part where if I took a picture of it, I could see this, and that is the photosphere. It's also where light is given off. Number five is the atmosphere of the sun, okay? Number five is the atmosphere of the sun. That's the chromosphere. Number six, oh, I lost it. Where is number six? Oh, down here. The outermost layer, it's the crown. It's the hazy layer. That's the corona. Very good. Number seven, these dark areas. What are those dark areas called? Almost like freckles. Those are sunspots. Very good. We're not going to talk about number eight. Don't have to worry about that. But I'm talking about these arching columns of gas down here, number nine. They have not left the surface yet. They've not left the surface. They're just columns that are connected. Yep, it's that P word, prominences. And if those arching columns of gases would leave, we would call those solar flares. But that's not what we're at yet. All right, we're almost done with these notes. One last thing, something that it's kind of complex, and if you take physics, we're going to talk about it. But for right now, I'm going to give you the simplest thing. These are called Kepler's laws, Johannes Kepler, okay? And he's a brilliant man, and there's a little bit of math with this, but I'm not going to test you on that. I just want you to make sure that you understand something. Planets orbit in something. When you're a kid, you draw the orbits of planets, okay? So if you drew the orbit of a planet, you would draw a circle. Well, truly, planets don't orbit in circles. Nothing really in the known universe orbits in what they call a perfect circle. They orbit in an oval, okay? But we don't say oval. We call them ellipses, okay? Not eclipses. Eclipses are different. These are ellipses. An ellipse is an oval. Okay, the farther out you are away, the more ovally or the more elliptical you become. The closer you are, the more circular or less elliptical you become. If Mercury, which is the closest planet to the sun, was elliptical, it might stretch out, but then when it got to the sun, it would hit the sun. We don't want that. So it's more circular. The Earth is pretty circular, okay, around there, because we're still pretty close to the sun. But if you got out there to like Pluto, Neptune, they get to become very elliptical. There's parts where they get closer to the sun and parts where they're really, really, really far out there. So what do you need to know? You need to know that planets orbit in what we call an ellipse or an oval, not a circle. Not a circle. Planets orbit in an ellipse and not a circle. Okay, I hope you enjoyed these notes. Again, these are the last of the astronomy notes. This is part 4. This is layers of the sun and orbits. All right. We'll see you next time. If you